So when we multiply a vector by a scalar, and by scalar we mean just a number, then we get a vector parallel to the original vector Now, when we say parallel, we mean in the same, well, it may not be same direction. So we mean, it could be in the same direction, but it could also be what? In a totally opposite direction. It could be 180 degrees the other way. So we get a vector parallel to the original vector. Now, if the scalar is 1, it's the same vector. But if the scalar is not 1, then it's going to have a different length or a different magnitude. So we get a vector parallel to the original vector, but if the scalar is not, well, it's not 1 or what? Negative 1. It's not 1 or negative 1, then the vector we get from the multiplication has a different length, and the length is the magnitude. So we can draw some pictures of this, some examples geometrically. And then we can also do this algebraically, but here's some geometric examples. So I'm going to have this. Suppose this is vector V. Vector V. And I want to draw 2 times vector V. Draw 2 times vector V. And draw negative 1/3 times vector V. So what do I do for 2 times vector V? Same direction, but it's going to be twice as long. So I'm going to do the best I can doing this freehand. Same direction. So I'm going to draw vector V and then double that length. So I'll call that one 2 times vector V. I'll put that next to it. And then, what about negative 1/3 times vector V? It's going to be in the opposite direction, parallel, and it's going to be 1/3 of that length. So I'm kind of looking at my vector V right here, and I'm eyeballing it, thinking, okay, 1/3 parallel, opposite direction, and I'll label that negative 1/3 times vector V. So we can do this geometrically, we can do this algebraically. If I want to do one algebraically, here's an example. So here's a vector. Let's call this one W, just to be different. W is this vector with these components. I'll just make something up. 5, negative 2 is vector W. Then I can say 2 times vector W is going to be 2 times the vector 5, negative 2. And you just multiply the 2 with the components. So it's going to be 2 times 5 is 10, and 2 times negative 2 is negative 4, and here's 2 times vector v. Probably be nice to graph this so you can get a picture of it. Let's see, 5, negative 2. I'm thinking ahead a little bit with exactly how I want to set up my axis here. So see, I have 5 and negative 2. So the position vector would have terminal point at 5, negative 2, and the initial point is at the origin. Here's vector w, and when I multiplied by 2, I'd gotten 10, negative 4. Let's go out to there, 6, 7, 8, 9, 10. Negative 4 would be this point. And my initial point, let me get my highlighter for this one. So 2 times vector w is right there. And that's probably a much better picture than the one I did, just looking at it geometrically. As I can see, it's twice the length of the first vector.